Okay, good morning class. So today we're looking at the last part of your finance. So what was the homework for today? It was exercise 11.6. Any issues with 11.6? Exercise 11.6. So no problems with 11.6. 11.7. Exercise 11.7, any issues there? You had to do the odd numbers there, correct? Even. Okay, no problem. So that is behind us. Nominal and effective interest rate, that's what we started on Thursday. Alright. So, any issues here? Number 9. Okay, we only did example 1 and 2, correct? So we've worked from calculating your nominal interest to an effective interest rate. That's the only thing we did in the previous lesson. Okay, so today, in today's lesson, we're going to work the other way around, which is example 3, and the balance of exercise 11.8 will be your homework. Okay, so I'm going to explain to you how to do calculating your effective interest rate to a nominal interest rate. Okay, that's today's work. And we're going to start with our chapter on probability as well today. Okay. During tomorrow's lesson, during the cycle test lesson, you guys will come for a maths lesson as well. Okay. So if anybody wants to intercept that lesson, you know, you're taken already. No? Right. So out of 11.8, it is number 9. Convert a nominal interest rate, okay? This is exercise 11.8. That's on page 388. Okay. Alright, so the question says convert a nominal interest rate of 6.5% compounded quarterly to an interest rate per annum compounded monthly. Okay, this sum I will do after I explain example 3. The reason for that is the first part is simple. The first, so we're going to do the part that you could have done, which is 1 plus I effective equals 1 plus I to the exponent m over m to the m. So what we do is 1 plus I effective equals 1 plus 0,065 over 4 to the exponent 4. So your effective interest rate is simply, there's an easier way of doing this, but for now we'll just stick to this until we do past papers. There's a few sums dealing with exactly the same thing, but I'll explain to you that at a later stage. So it is definitely an easier way. I don't want to confuse you at this point. Alright? 0, the exponent over 4. Okay? Times 100. So you give effective interest rate of 6,66. 6,66%. Now, you see, now I got an effective interest rate. Not so. And then we must convert it to a nominal. So that's in today's lesson. Okay, I think I'm going to first finish this, and then we can do example 3 rather than together. Okay? So from here we're converting, so this is a new work now. We're converting an effective interest rate to a nominal interest rate. Okay? So this is what we have and that is what we want. to calculate. You all understand the scenario? Are you all with me? Yes. So, what is the effective interest rate? 6.66%. So in other words, it's 1 plus 0.066, and the number of course carries on, equals 1 plus. This is compounded monthly. How many months are there in 1 year? 12 parts, no? So it's going to be I to the exponent 12, or I to the m. That would have been 12 now. But since that 12 have no bearing on that I can just leave it out. Okay? Yeah, already we replaced I effective. Can you see we replaced it already? So there won't be two I's in the formula any longer. You guys understand? Otherwise, if you want, I can just write I to the 12. And it's over 12 to the exponent 12. You all okay with that? So what is the first thing we need to do? What's the first thing we need to do? Okay, we're going to add this here, not so? And then we're going to take the 12th root here. You all agree with that? Okay, so it's going to be the 12th root of 1,066, and the number of course carries on, equals 1 plus I to the 12 over 12. Okay, so let's put that in the calculator. So it's the 12th root. Whoops. The 12th root of 1 plus answer. No. Let's first check what the answer is. I think it's, yeah, so we must first divide by 100. So in other words, that's 0,0666. We add 1 to it. We take the 12th root thereof. Gives you 1,005, and the number carries on. Not so. So what do you think we're going to do now? Divide it by 12. How do we normally get rid of the 12? Not divide by 12. Times by 12. But you're doing that prematurely. You're doing that before the time. What must be done prior to that? What must be done before that? Like the 1 over, not so. So it's going to become minus 1. Not so. Am I moving too fast? So remember that is times 10 to the minus 3. If you need to get it in decimal, please shift engineering, we get 0,005 there. Now what do we do? What do we do thereafter? So 0,005, and the number carries on, equals I. What do we do now? Multiply by 12 both sides. Not so. It's going to be that answer times 12. Whoops, divided by 10 times 12. Okay, and then I multiply it by 100 to get the rate. So your rate for compound monthly is equivalent will be 6,47%. Okay. There's a lot to process now at this point. So what we're going to do is we're going to do example 2 quickly. Maybe it will make more sense. Okay. This is example 3 on page 288. 388. So we are told convert an effective interest rate So effective is what? What is an effective interest rate? A yearly interest rate. Not so. So it's going to be 1 plus I effective equals 1 plus I to the m over m to the exponent m. Okay? Convert an effective interest rate, so that is that value, of 8.5% compounded annually to a nominal interest rate compounded quarterly. So this will be over 4 to the exponent 4, and that is what I will be calculating. You will agree with that? See any confusion? No. Alright? So do the substitution quickly. Okay, so what do we get? 1 plus, what's the effective rate? The I value is 0.085. Remember, this is R effective, no? That's your effective rate. I is equal to R over 100. Okay? Into 1 plus I to the 4 over 4 to the 4. You all agree with that? Any confusion? Okay, so what do we do now? We add the 1 yes, and then not everybody at once. Yes? The fourth root yes. So do that quickly. Add and then the fourth root. Right, once you got that answer, what do we do? What do we do? Minus 1, yes. So do that quickly. Then what do we do? We multiply both sides by what? 4. And then we multiply it by 100. So do that quickly. I get 8.24. Is that correct? Is there anybody that's confused? Any confusion here? Any questions regarding the sum? Yes, Michael? Since that is going to be I to the 4, they want the rate, and the rate is, you see here, your rate is going to be 100I. That is why I always from I to R I always multiplied by 100. No? Any other confusion? You all okay, no? Do we need to do another example like this, or do you understand? Understand, okay. You understand? Another example? Boring. Okay, another example. Okay, we're going to do number. You did number 1 for homework, no? Convert. Number 2? Convert the interest rate of, right, number 2 we're going to do out of exercise 11.8. You do for me number 2. Please put your phone on silent if you don't mind. I just realized now that we haven't done depreciation yet, no? And we'll have to do depreciation first before we go into probability. So we need to wrap up that today as well. Okay? Okay, you guys finish? Right? So in exercise 11.8, number 2 on page 388, they ask you to convert an interest rate of 11.25% per annum compounded annually. So it's 1 plus I effective equals 1 plus I to the M over M to the exponent. Why do you think I'm writing the formula down all the time? Start memorizing. Remember, this formula is not given in the exam. So if they ask you to convert an effective to a nominal compounding or vice versa, you must be able to draw this formula out to read. Write down the formula out to read. So 1 plus, they ask you to convert an interest rate per annum compounded annually. That makes it an effective interest rate. So 0.1125 equals 1 plus, what's your I value? Interest 0.1125. No. Compounded quarterly, so it's I to the 4 over 4 to the exponent. You okay with that? So what do I do first? You add the 1 to that, what do I get? 1.1125. Then what? What do you do after this? The fourth root. Okay, so then by taking the fourth root, I got rid of this bracket. Not so? Then what do? Take the 1 over. So it must become minus 1. Then what? Multiply by 4, which is that there. So the whole number must be multiplied by 4 to get I to the 4 on its own. Not so? But what do they want? They want the rate. So what do? Multiplied by 100. So it's going to be 4, open brackets, the fourth root of 1,1125, or your answer if you had plus 1 on your calculator, close brackets, gives me 0,108, you times by 100, gives you 10,8%. Okay. Any confusion there? You all get it right? Okay. Anybody get it wrong? So for homework, I would like you guys to complete the exercise. Whichever sums was not completed on page 388 and 389 out of exercise 11.8, please complete it. Okay. Depreciation. Let's cut this here. Okay, so we are told that depreciation, okay, it's basically cut off here. Let's cut it properly. So we are told that depreciation is a loss of value of an asset through use or age. Okay, so if we look at, for argument's sake, a cell phone. Okay, over time, cell phones lose its value, not so? So if you had paid, I don't know if they still make BlackBerry. They still make BlackBerry. No? That time BlackBerry was the top phones. No? Everybody wanted a BlackBerry, and that was probably one of the most expensive phones back then. Okay, within its category. All right. So if you look at the BlackBerry today, you would never pay that amount that it was worth 3 years ago, 5 years ago. At the same price, you understand? Likewise with a car, okay? If you buy a brand new 2021 car this year, you with a new model coming out the following year, the value of that car, even though that car wasn't owned by anybody before, a year later, or with the new model coming out, that car then loses value. You understand? So there's many factors that depreciates equipment or things. Okay, you guys understand? So through age or through use, okay, depreciation normally is calculated in two ways. Okay, it can be calculated on the reducing balance method, and it can be calculated on straight line basis. Now if you're looking at items that would depreciate on straight line basis, if you take a computer, a laptop of 10 years ago, say the laptop costed 5,000 Rand 10 years ago. Would you be willing to pay 5,000 Rand for a 10-year-old laptop? No, the laptop will be worth nothing to us. Not so. However, if you take a Jaguar or a car of 10 years old, say the car is R1 million. Okay, today would that car be worth nothing? No, it will still be worth something. Not so? Probably 300,000, 400,000 for the vehicle anyway. So that would then be calculated on the reducing balance method. When you got the vehicle or the equipment maintains a value, okay, it will then be considered depreciation on the reducing balance method. It will always be worth something. Whereas a computer will be worth nothing over 3 years or 5 years, for argument's sake. So a computer will be calculated using depreciation on straight line basis. Does it make sense? Okay. Hi boss, morning. Okay, so let's see what they said. Does it make sense, people? So what do you think cell phones? Cell phones will be straight line basis or reducing balance? Reducing balance. What are you willing to pay for a 10-year-old phone now? 20 rand. You can't WhatsApp with the phone. You can't do anything today with that phone. Other than just phone and hello, goodbye. That's it. Still willing to pay 20 rand? Alright, the cell phones we have at home, I got 4 of those. So you bring 80 rand tomorrow. Okay. Hello and goodbye. Right. What the rest of you think cell phones should be? Straight line depreciation or reducing balance? Straight line depreciation. So it will be worth nothing after a few years. What do you think of equipment? Reducing balance. Like if you're looking at the bakery, a mixing machine. Okay. An oven. Okay. In the bakery's settings, the oven will always be worth something. Not so even if the oven is worth, I'm 10 years old. Somebody else will be willing to buy that oven still. Industrial oven for argument's sake. You guys understand? Right. So straight line depreciation is calculated as a percentage of the original value of the asset, and it is the same each year. So the depreciation of that item, as we have simple interest, okay, it has a consistent interest that is added every year to that value. Whereas with compound interest, once you have calculated the interest for that time span, say compounded yearly, that interest that gets added to that value forms now the new principal of the following year. Not so? Likewise with depreciation on reducing balance, the same thing happens. Okay? So what happens is over time, over time what happens is depreciation on straight line basis, that's what's going to happen. So after 8 years your computer is worth nothing. Okay, that's what's going to happen there. Whereas on a vehicle, so you paid whatever you paid for the vehicle, the principal amount, this is what this graph would look like. Okay, it's a reducing balance. Okay, it's the decreasing exponential function. Can you see that, people? So as I said, the value or your equipment or your vehicle will always be worth something. Okay, so this is what the graph for depreciation on the reducing balance would look like. Whereas depreciation on straight line basis will look like that, because after a certain number of years the item will be worth nothing. Okay. Reducing balance calculate percentage of the previous year's value. In this case, the depreciation changes each year and decreases as the asset loses value. With reducing balance depreciation, the asset will always retain some value. Okay, that's what they basically tell us here. The book value is basically what the value of the item is at that point. Okay, so if you're looking at the diagram that I drew in the first case, that would be the book value after 8 years, it will be worth nothing. If they ask you to work out the book value after 2 years, it will be still worth something. In 4 years, 6 years, and so on. 8 years will be, in this case, nothing. Likewise here, you could work out what the book value is at that point and so on. Alright, you guys understand? You all understand, people? And here they explain to you in the second paragraph, they explain to you when would you use straight line basis and when would you use the reducing balance method. Okay, you guys understand? Right. Now the formulas So you guys can write this down. The formulas for depreciation is as follows. The formulas used to calculate depreciation. Straight line depreciation, A is equal to P into 1 minus I times N. What do you notice? What is the only difference between this formula and the formula that we've used prior to this? The minus. Okay, and I'm sure some of you do accounting. Who of you do accounting? Right? You've dealt with this formula before, not so? You probably did, but you didn't take note. Even you didn't take note. You don't do depreciation. What formula you use? You can't give me the formula. Sorry? Okay. I'm sure you can use this formula. If you can't use it, then you just show me how that formula looks. Okay, so that we can see the difference between it. But I would assume that you would do the same. I also did accounting. I would remember using something else. Huh? Then again, my memory is not good. Right, reducing balance depreciation. A is equal to P into 1 minus I to the exponent N. So that is the difference between this formula and the compound formula. Again, just the minus. Not so? Where A is the value of the asset after depreciation, P is the original value or the principal value of the asset. N is the number of years after the asset was purchased, and I is the rate of depreciation per annum of the asset. Are you all okay with that? Any confusion? No. Right, let's look at example 1, and this is on page 390. Example 1, page 390. I really thought you were done with this one. I prepared myself for a good probability lesson today. How do I prepare myself for a good probability lesson? I'm going to bed early. Yes? That's not going to happen 2 nights in a row. Right, page 390. Okay, so we are told that a set of computers is bought by a company for 580,000 rand. These computers are depreciated by 25% on straight line basis. First question says calculate the book value of the computers at the end of 3 years. So what do you think? How are we going to calculate this? How are we going to do this calculation? Use the formula. Which formula? Straight line basis. A is equal to P into 1 minus I times N. Do you all agree with that? Do you all agree with that?
Yes.
Right. So do the substitution and do the calculation. You all got that substitution? The 580,000 into 1 minus 0.25 times 3. You all get 145,000 Rand. B. What is the book value of the computer after 4 years? So what do I do here? Same formula, yes. But what's the difference in substitution here? The years is 4 years. Can you do that quickly? Right, so we said that the end value will change. So A is equal to P into 1 the formula is written down, I don't know why I'm writing it down again. It's 580,000 into 1 minus 0.25 times 4, since it's 4 years. Did you give me the answer? So what does that mean? After 4 years, yes? The computers will be what? Okay. You will understand what this is, the book value is 0. You all okay with that? Right, let's go to example 2. Example 2 is on page 391. Example 2 is on page 391. A farmer buys a combined harvester for 1.45 million, or that is also 1,450,000. Okay? Calculate the value of the harvester at the end of 5 years. Okay, there is an idea, no? If you want to come to the matric ball in style, the expensive vehicle, get you a combined harvester. No, that won't work. No? Don't think you can ride on the roads. What's the name? The solution by mistake. I cut the solution by mistake as well. Alright. So 1.45 million Rand. Calculate the value of the harvester at the end of 5 years. If depreciation is calculated at 18% on the reducing balance. So what do we do here? Reducing balance formula, which is A is equal to P into 1 minus I to the exponent N. So do the substitution quickly. You all agree with that substitution? 1,450,000 into 1 minus 0.18 to the exponent 5. You all agree with that? So it gives you 537,000. 537,000. 527. 72. Comma. 77. Any confusion there? What would the combined harvester be valued at after 10 years? 200,000. Finish it. After 20 years, it will be 27,393 now. That's 20 years. Maybe after 25 years, 10,000. Can you see? After a long span of time, the harvester will still be valued at something. Alright, you guys understand? It's example 2. Is there any confusion here, people? No. Look at example 3 on the same page. So this example here on page 390. A company buys a front-end loader at a cost of 1.8 million, 1,800,000. The book value of the front-end loader at the end of 4 years is 720,000.
My apologies for the interruption. Alyssa Heltzinger, can you please report to office?
Okay, so what value is this, people? This is going to be what? Your P or your A? P value, your starting value. And this here, of course, A value. Calculate the annual rate of depreciation if a depreciation is determined on, in the first case, straight line basis. So if it says straight line basis, what must we use? Same formula. A is equal to P into 1 plus, 1 minus I times, sorry. So what is your A value? 720,000 into 720,000 equal 1,800,000 into 1 minus I times N, which is 4 years. All agree with that? I'm sure at this point you all can calculate I. So calculate I quickly. Okay, so firstly we're going to divide by 1.8 million. So 720,000 over 1,800,000 equals 1 minus I times 4. Now what do we do? Take the 1 over. Okay. Once I take the 1 over, what do I do thereafter? Divide by negative 4 both sides. So you're right. How do I get from I to R? times by 100. So 720,000 over 1,800,000 minus 1 over negative 4. Times by 100 gives you 15%. Any confusion here? If we ask you on the reducing balance, people, what do you do for reducing balance? Use the other formula. What formula is that? A is equal to P into 1 minus I to the exponent. Right? So your A, your I, your P, and your N value is the same. So do the substitution and then make I the subject of your formula. Okay, the bell's gonna ring soon. So the first thing I'm going to do is I'm going to divide 720,000 by 1.8 million. Gives me 2 over 5. Then what do we do? Take the fourth root both sides. Okay? And then what do we do thereafter? Take the 1 over. So I'll get negative I on its own. And then divide by negative 1 both sides. And then multiply it by 100. Not so? You will agree with that? So you say the fourth root. I'll get the answer calculated. Alright? Minus 1. And all of that is over negative 1. Then multiply it by 100. With 20,47%. You all get that? Okay. Any confusion, people? Right, for homework? So there's one example left, I think. Yeah, one example. I'll do that tomorrow. Remind me, I will do it at the beginning of the lesson. Okay? Before we go into the homework. For homework, I want you guys to do exercise 11.9. Number 1. One to number 8. 1 to 8. People enjoy the rest of your day. Good afternoon, class.